Hello, I'm Seema and welcome to part 4 of the chapter Solutions. In the previous two videos, I explained how we express the concentrations of solutions. And in the previous part, that is in part 3, we solved a few solved examples of this topic. I'm now going to solve question 2.2 to 2.5 of the in-text questions in order to clarify the concept to you further. And after this, I would be doing a little bit of normality, although it is not there in the NCERT syllabus. Yet, in your competitive examinations, and a little knowledge about normality is beneficial. So I'll cover it in a short video, but I'll do that also. So let us just get to it. This is question 2.2. The question reads, you have to calculate the mole fraction of benzene in solution containing 30% by mass in CCl4. It means you have a solution of CCl4 and benzene. So benzene and CCl4 are present and you have 30% of benzene, which means the solute is benzene and the solvent is CCl4. And what is asked is the mole fraction. You remember I told you in the previous part, and I keep telling you whenever I solve numerical problems, that whenever they ask you something, write down the definition of that particular thing which has been asked. When you write down that definition or the formula of that thing, you have an idea what is expected of you. And once you reach what is expected of you, you can solve the problem. That becomes the final step. So we start always with the final step, that what is expected. You are asking for mole fraction of benzene. And we know mole fraction is represented by X and benzene is C6H6. So mole fraction of benzene would be equal to the number of moles of benzene, C6H6, upon the number of moles of all the components, that is C6H6 plus the number of moles of CCl4. So this is what we want. What is given to us? We've been given the mass percentage. You have 30% of benzene by mass. So if we say, let us assume that mass of benzene is equal to 30 grams. Then what would the mass of CCl4 would be equal to, now if out of 100%, 30% is benzene, then CCl4 is the remaining mass. So if you have a 100 gram solution, then if 30 grams is benzene, then CCl4 would be 100 minus 30, which is equal to 70 grams. From this, we know the ratio, or rather we know the masses. We've just assumed in the proper ratio the masses of both the components. And our aim is to find out the number of moles. If we have to calculate the number of moles of anything, then how do you calculate? The number of moles of anything, for example, we are taking C6H6, that is benzene. Number of moles of C6H6 would be equal to the mass given upon the molar mass of benzene. Now, in order to calculate the number of moles of benzene, we should know the molar mass of benzene. Similarly, in order to calculate the number of moles of CCl4, we should know the molar mass of CCl4. And the masses, of course, we have already imagined them to be 30 grams and 70 grams. So let us calculate. In order to do this, first we'll have to find out the molar mass. So molar mass of C6H6 would be equal to, how do you calculate it? There are 6 atoms of carbon and each atom is 12 grams. You're taking the molar masses into 6, plus there are 6 atoms of hydrogen and each atom weighs 1 gram. So 1 into 6. So 12, 6 is 72 plus 6 would be 78 grams. The molar mass of benzene comes out to be equal to 78 grams. From this, you can calculate the number of moles of benzene. Therefore, number of moles of C6H6 would be equal to, it is the mass upon mass, given mass upon molar mass of benzene. And the given mass of benzene is 30 grams and molar mass is how much? 78 grams. So 30 grams upon 78 grams, the grams would get cancelled and the or rather grams per mole. You will get it in, you'll get the number of moles since the grams will be cancelled out. And this will be equal to 0.3846. 0.3846 moles. Right? You've calculated the number of moles of benzene. Now, in order to come to this is something that you have now. What you need is number of moles of CCl4. In order to calculate the number of moles of CCl4, you need to know the molar mass of CCl4. Now, the mass of carbon is 12 and there's only one atom, so into 1 plus there are 4 chlorine atoms and the mass of one chlorine atom is 35.5 into 4. So 12 into 1 plus 35.5 into 4, when you calculate this will come out to be equal to 154 grams per mole. 154 grams per mole is the molar mass of, this was also grams per mole. Units are important. So this was the molar mass of CCl4. And in order to calculate the number of moles of CCl4, you need to write the mass of CCl4 upon the molar mass of the component. And the mass given for CCl4 is 70 grams upon 154 grams per mole. Right? And when you solve this, how many moles do you get? The number of moles of CCl4 you get is 0.4545. 0.4545 mole. Now we have all the required quantities. We have the number of moles of benzene, and we have the number of moles of CCl4. So find out the mole fraction. XC6H6 mole fraction of benzene would be equal to number of moles of C6H6 upon number of moles of C6H6 plus number of moles of CCl4. And now substitute these values. What do you get? 0.3846 mole upon, since all units are number of moles, therefore the units would get cancelled and the fraction would only be a number. So you get 0.3846 upon 0.3846, that is number of moles of benzene plus number of moles of CCl4, which is 0.4545. And when you solve this, the answer you get is 0.458. 0.458 is the mole fraction that you're looking for, right? So now give me a moment, I'll write the next problem. All right, so now this is question 2.3 in text question. The question reads, you have to calculate the molarity of each of the following solutions. So the question has two subparts. The first one is A, 30 grams of cobalt nitrate hexahydrate is in 4.3 liter of solution. Whenever they do not mention the solvent, we assume the solvent to be water. And the second part says that you have 30 ml of 0.5 molar H2SO4 solution, which is H2SO4, which is diluted to 500 milliliters. And you have to calculate the molarity. We'll come to part A first. Whenever you have to calculate the molarity, again, you must write down the definition of what is required. So the first is molarity, M, is equal to the number of moles of solute, number of moles of the solute upon volume of solution in liters. Right? Now we know this definition, that it is the number of moles of the solute. What is the solute here? You have 30 grams of cobalt nitrate hexahydrate. So you've been given the mass of the solute and the volume of the solution. So the volume of the solution is given in liters. So this part you already have, but you have to calculate the number of moles of the solute. In order to find out the number of moles of anything, the number of moles is equal to the mass divided by molar mass. And in order to do that, you need to have the molar mass. So let us first calculate the molar mass of cobalt nitrate hexahydrate. CONO3 whole twice 6H2O. Now this is cobalt nitrate hexahydrate and you have to find out its molar mass. The mass of cobalt is 57 into 1 because there's only one atom of cobalt, plus the nitrate is multiplied by 2. So you write 2 and put it in a bracket. The mass of nitrogen is 14 into 1 plus oxygen is 16 and there are 3 atoms of oxygen, so 16 into 3, and all of this is to be multiplied by 2, and there are 6 molecules of water. So 6 into water, 2 atoms of hydrogen, and the mass of hydrogen is 1 into 2 plus oxygen is 16, that is 18 into 6. And when you solve all of this, the molar mass of cobalt nitrate hexahydrate comes out to be 291 grams per mole. When you calculate this, you'll get 291 grams per mole is the molar mass. Now that you have calculated the molar mass, you have to calculate the number of moles. So how do you calculate number of moles from this? Number of moles is equal to the given mass upon molar mass. And what are we calculating the number of moles of? We are calculating the number of moles of cobalt nitrate, NO3 whole twice 6H2O, cobalt nitrate hexahydrate, and the number of moles. So the mass given to us is 30 grams, and what is the molar mass that we calculated? 291 grams per mole, right? The grams and grams will get cancelled and mole will come in the numerator. You will get the number of moles. And what is the number of moles that you calculate? It is 0.103. 0.103 moles. Now that you have the number of moles of the solute, that is cobalt nitrate hexahydrate, and the volume of the solution is given to us, which is in liters, so molarity would be equal to number of moles, or let me just write N, number of moles of cobalt nitrate hexahydrate upon the volume of solution in liters, or L, capital L, in liters, right? The number of moles that we calculated, 0.103 moles, and the volume is how much? 4.3 liters. So when you solve this, you'll get the answer in moles per liter, which is molarity. So you get 0.023. 0.023 moles per liter, which is also equal to 0.023 M, capital M, which is for molarity, which means moles per liter, right? Let us now come to part 2. So now the second part asks you that you have 30 milliliters of 0.5 molar H2SO4, which is diluted to 500 ml, and you have to calculate the molarity of the solution. Now, we know that molarity, this is part B that I am solving now. Molarity, the definition of molarity is number of moles of the solute. So we need to find out the number of moles of solute and divide it by the volume of the solution in liters. The volume of the solution, final volume given to us, is 500 milliliters. And 500 milliliters in liters would be take it 3 decimals here, so it is 0.5 liters. So we have the volume again, and we have to find out the number of moles of solute in 30 milliliters. So 30 milliliters of 0.5 molar H2SO4 solution was taken. So we had 0.5 molar solution. What does 0.5 molar solution mean? It means that 0.5 moles of H2SO4 is present in 1000 ml of the solution. Right? When we say it is 0.5 molar solution, it means that it is 0.5 moles of H2SO4 is present in 1000 milliliters of the solution. And out of this solution, we have only 30 milliliters. So we will have to calculate, we are not using all the 1000 ml of the solution. So if 0.5 moles were present, they were present in 1000 ml. So in 30 ml, what is the amount that would be present? How many moles would be present? So we can find that out by unitary method. We say that in 1000 moles, in 1000 ml of the solution, H2SO4 present is equal to 0.5 moles, right? So in 1 ml, how much would be present? Upon 1,000. And in 30 ml, how much would be present? It would be equal to 0.5 upon 1,000 ml moles into 30 ml, right? So from this you will get the number of moles. The ml and ml will get cancelled. You will get the number of moles that are present in 30 milliliters. Now you have found out from this, you have found out the number of moles of the solute, and the volume of the solution in liters is given to us. So when you calculate this, what do you get? You get 0.015 mole. This would be equal to 0.015 mole. What is this? This is volume, this is the number of moles of H2SO4. So in order to calculate the molarity, you have to write down the number of moles of H2SO4 upon volume of solution in liters. So this is equal to 0.015 mole upon volume of solution in liters is 0.5 liters. 500 ml is 0.5 liters, and therefore when you solve this, whatever answer you get would be in moles per liter, and the answer that you get here is equal to 0.03 molar solution. 0.03 moles per liter, which is equal to 0.03 molar solution, right? So let us now come to question 2.4. Alright, so now this is question 2.4. The question reads, you have to calculate the mass of urea, that is NH2CONH2, required in making 2.5 kg of 0.25 molal aqueous solution. Now you have 0.25 molal aqueous solution. What does molal mean? It means the number of moles present in 1 kg of the solvent. So the number of moles of solute divided by the volume of solvent in kg. So you have to calculate the mass of urea. You're required to find out the mass. So you have 0.25 molal solution. What does 0.25 molal solution mean? 0.25 molal solution. It means that 0.25 moles of urea, that is NH2, let me write urea only, it's smaller, of urea is present in 1000 grams of, or 1 kg of solvent, that is water, right? Now in order to find out the number of moles, you need to know the molar mass, or rather here you are asked the mass. You have to calculate the mass. In order to come to the mass, you must first know the molar mass of urea. Let us calculate the molar mass. The molar mass of urea, now I write the formula, NH2CONH2. The mass of nitrogen is 14, and there are 2 nitrogens, plus mass of hydrogen is 1, and there are 4 hydrogens, plus 1 carbon, that is 12 into 1, plus 1 oxygen, 16 into 1. When you solve this, this comes out to be equal to 60 grams per mole. The mass of urea is 60 grams per mole, right? Now, what does, if you had 1 molar solution, it would mean that you have 60 grams of urea in 1000 grams of water. 1 molar would have meant, so 0.25, if 1 mole is 60 grams, then 0.25 mole is how many grams? So 1 mole is equal to 60 grams of urea. Then 0.25 mole of urea would be equal to 60 into 0.25, which is equal to 15 grams. Now 15 grams of urea is present in 1000 gram of water. But here the 2.5 kg that is given to us is the mass of the solution. It is not the mass of just the water, that is the solvent. Because what is molality? Molality is number of moles of the solute divided by the mass of the solvent in kg. But we have been given the mass of the solution. So we will have to take that mass into consideration. The 1000 grams is of the, so what is the mass of this solution now? Of this 0.25 molar solution. In 0.25 molar solution, mass of urea is 15 grams and the mass of the solution would be equal to 1000 grams of the solvent, that is 1 kg, plus 15 grams, that is of the solute, which is 1015 grams is the mass of the solution. So now if we have to make this up, if we want to know the mass in 2.5 kg of the solution, let us use unitary method. By unitary method, 1015 grams of solution contains urea equal to 15 grams, right? So 1 gram of solution will contain 15 upon 1015. And how many grams do we have? 2.5 kg becomes 2500 grams. Would have 15 upon 1015 into 2500. And when you solve this, this will give you how many grams, and you'll get it in grams, how many grams of urea is present in 2.5 kgs of the solution. The answer you'll get would be 36.95 grams, which is approximately equal to 37 grams. Right? So this is how you solve question 2.4. Let us move to question 2.5. And here comes the last question for today. The question is question 2.5. It reads, calculate A, molality, B, molarity, and C, mole fraction of potassium iodide if the density of 20% by mass of aqueous potassium iodide is 1.202 gram per milliliters. Now you have to find out the molality, molarity and mole fraction. So there are 3 steps. We've been given the mass is 20% mass by mass ratio. The solute is potassium iodide and the solvent is water because it is an aqueous solution. So the first thing, let us come to first. We are supposed to calculate the molality. And we know molality, LITY, is equal to the number of moles of solute upon the mass of solvent in kgs, right? Now, in order to arrive at these 2 values, so that we can use this formula, let us find out what all we need. What all do we have? We have 20% by mass of aqueous potassium iodide. So let us assume mass of Ki is equal to 20 grams. If mass of potassium iodide is 20 grams in a 100 gram solution, then the mass of water automatically would be equal to 100 minus 20, which is equal to 80 grams. So you get the mass of water is 80 grams. And water is the solvent. And what about its mass in kgs then? If it is 80 grams in kgs, it will be equal to, take it down here, 3 decimals, so it will be 0.08 kilograms, right? So one value, that is the denominator, we already have. Now we have to find out the numerator, the number of moles of solute. What is number of moles? Number of moles is the mass upon molar mass. The mass given to us is 20 grams, so we need to calculate the molar mass of potassium iodide. In order to calculate the molar mass of potassium iodide, molar mass of Ki, this is 39 plus 127. The mass of potassium is 39 and iodine is 127. The molar mass comes out to be 166 grams per mole is the molar mass of potassium iodide. So now you get 166. Molarity now, number of moles of Ki would be equal to mass upon molar mass, and mass given is 20 grams and molar mass given to us is 166, right? And 20 upon 166 will give you the number of moles. And what is molality? Molality, small m, is equal to number of moles of Ki divided by the mass of solvent in kg. Mass of the solvent in kg. So this comes out to be 20 upon 166 is the number of moles divided by the mass of solvent in kg is 0.08. And when you solve this, you will come to 1.506 molar solution, right? So the first part is you have to calculate the molality, and the molality of potassium iodide would be 1.506 molar solution. Let us now do the part 2. Now for part B, you are supposed to calculate the molarity. And we have already found these in part 1. We've calculated the molar mass of potassium iodide, which is equal to 39 plus 127, which is 166 grams per mole. And we calculated the number of moles of potassium iodide, which was 20 upon 166, which comes out to be equal to 0.12 moles. This is information that we already have. Now, in order to find out the molarity, you again need to know the definition. What is molarity defined as? Molarity is equal to the number of moles of solute upon volume of solution in liters, right? Now the volume of solution in liters, we do not have the volume. The number of moles of solute we have already calculated, it is 0.12 moles. But the denominator we don't know, the volume of the solution. Now what is given to us and how can we calculate the volume of the solution? We've been given density. So what is density? Density is equal to mass upon volume. So what is volume? From this you can calculate volume. Volume is equal to mass upon density. Now what is the total mass of the solution? 20 plus 80, 100 grams. We assume the mass of the solution to be 100 grams. So this would be equal to 100 grams upon, the density is in grams per milliliter, 1.202 gram per ml. Right? Now when you calculate this, the volume comes out to be equal to 83.19 ml. And in liters, what would this be equal to? Take it down 3, it will be 0.083 liters, right? So now you can calculate molarity. What is molarity? I'll repeat it again. Number of moles of solute upon volume of solution in liters. Now we have both the numerator and the denominator. The numerator is 0.12 and denominator is 0.083 liters. And this is moles. So you'll get your answer in moles per liter. When you solve this, what is the molarity that you get? The molarity is 1.45 molar solution. 1.45 molar solution or moles per liter. Now the third part of the question is that you have to find out the mole fraction. In mole fraction, what is mole fraction? Mole fraction is number of moles of the solute divided by the total number of moles of the solute and the solvent. So let us now write down the mole fraction. Mole fraction is represented by X. mole fraction of Ki would be equal to number of moles of Ki divided by number of moles of Ki plus number of moles of water. Now we have number of moles of Ki is 0.12 and we have to calculate the number of moles of water. How do you calculate the number of moles of anything? The number of moles is equal to mass upon molar mass. So number of moles of water would be mass of water upon the molar mass of water. The mass of water, if Ki was 20 grams, then water was 80 grams and the molar mass of water is 18 grams per mole. So the grams will get cancelled and you'll get your answer in number of moles. So the number of moles of water will come out to be equal to 4.44. 4.44 is the number of moles. Now put it in X, Ki is equal to number of moles of Ki upon number of moles of Ki plus number of moles of water. So number of moles of Ki is 0.12 upon 0.12 plus 4.44. And when you solve this, you'll get the mole fraction which is equal to 0.0263. 0.0263 is the mole fraction of Ki in water. So these were the in-text questions, and in the next video I'm going to start teaching you about solubility. If you found the video helpful, please give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching and bye-bye for now.